In today's lesson, we're going to continue talking about angles. Two angles are congruent if they have the same measure. So this term is really, really important. Oh, look at all these different colors. The word congruent is really, really important in geometry. And the symbol we use for congruent is an equal sign with a little wavy symbol above it. So for example, here we have two angles, angle H and angle F. And they're both 37 degrees. So they have the same measure. So that means these two angles are congruent. So how do we write that with notation? Well, we're going to write angle H and then use this congruent symbol to angle F. So that tells you that these two angles are congruent, which means they have the same measure. Now, similar notation, but it's important that you understand the difference, is in this one we're saying the measure of angle H equals the measure of angle F. So when we talk about the measure of an angle, that's actually referring to a number. So when I say the measure of angle H, I'm talking about 37 degrees. And when I talk about the measure of angle F, I'm talking about 37 degrees. There and there. And so two numbers are equal. You use an equal sign for numbers. On the other hand, we use this congruent symbol for objects. So an angle is congruent to an angle, whereas a number is equal to a number. So it's really, really important you understand the difference of when to use equal and when to use congruent. And like I said, we'll be using that for the rest of the year, that symbol. All right, so now let's focus on an angle bisector. We've already talked about a midpoint of a segment. A midpoint cuts a segment into two congruent segments. An angle bisector has the same idea. An angle bisector is going to be a ray or a line that starts at the vertex of an angle and divides the angle into two congruent angles. So the rest of the time I'm going to go through some examples to make sure you understand the connection here. All right, so here's a picture, and we have actually three angles. We have the two smaller angles, angle CUS, let me trace that out, angle C to U to S, that's one angle, and then we have angle S to U to B, that's another angle, and then of course we have the entire angle C to U to B. So there's three different angles in this picture. Let's get rid of all these extra lines. There we go. Okay, so if I tell you that ray US bisects angle CUB, that means that this smaller angle has the same measure as this smaller angle. And we mark angle with curves. So that's one way to mark that the angles are congruent. Another way we could have marked it is maybe with two double curves. That would also work. Another way we could mark that they're congruent is a curve and then two tick marks. So there's lots of different ways we can mark that. But as long as the two markings match, that means the two angles are congruent. And we know that because the angle is being bisected. Bi meaning two, sect means to cut. So to cut into two equal pieces. Okay, so here's the examples. First one, they're telling us that ray AT bisects angle HAM. So where's HAM? Here's H to A to M. That's the big angle. And AT, this ray bisects it, which means it cuts it in half. So that tells me that I can mark this angle here equal to this angle here. I'm sorry, the angles are congruent, so their measures are equal. Now the measure of angle MAT is 32 degrees. So I'm going to go over to my picture and I'm going to look at angle M to A to T. That's right here, and that's 32 degrees. Well, since we know that the two angles are equal to each other, that automatically tells me that this angle is 32 degrees. Now, what do they want us to find? They want us to find the measure of angle MAH. Well, where's that? M to A to H. That's this entire angle, the whole thing. So I'm just going to add the 32 plus the 32, and that gives me 64. So the measure of angle MAH is 64 degrees. Okay, let's look at a different example. On this one, they're telling us the first thing is that ray AU bisects angle CAL. So C to A to L, that's the big angle. So if it's bisecting, that means it cuts these two angles, cuts the big angle in half into two congruent smaller angles. Now what else do they tell us? The measure of angle CAU, so where's C to A to U? That's this one here, 3x plus 7. And then the measure of angle U to A to L is 4x minus 10. So that's this one here. Find the measure of angle LAC. That's the entire thing. So obviously we're going to have to find x first. So to find x, we need an equation. We need to know what's equal. Well, we know what's equal because I made these red marks. And I knew I could make these red marks because they told me that AU bisected angle CAL. So this angle is bisected by this ray, which means this angle here is equal to this angle here. So I can just set this expression equal to that expression, and I'm ready to solve. So 3x plus 7 is equal to 4x minus 10. Lots of ways to do this. I would take away 3x from both sides first. Get my x's together on the same side. So that's 0. So I'm going to have 7 on the left side. 4x minus 3x is 1x, and I still have the minus 10. And then I'm going to add 10 to both sides to get x by itself. So that's going to be 0. 7 plus 10 is 17 equals x. Now, I just figured out what x is. That's not what they asked me to find. But I'm going to need to figure out what x is so I can find angle LAC. So angle LAC, let's trace that out. L to A to C, that's the whole thing. So what I could do is I could take this 17 and plug it in for x here, and I could plug it in for x here to find those angles and then add those angles together. Although I actually know they're going to be equal, so I don't have to do double work. So here's what I'm going to do. I'm going to take 3x plus 7, and I'm going to plug in 17 for x, because I just figured out x equals 17. So 3 times 17, that's 30 and 20, 51, plus 7 is 58. So I know that this angle here is 58 degrees. Now I can plug 17 into 4x minus 10. I don't need to. I know this is automatically going to be 58 degrees. So now, to find angle LAC, I'll just add 58 plus 58, which is 116 degrees. And there's my answer. So there's a lot of stuff going on here. First, we have to mark the picture with what they give us. Then we have to figure out what's equal. And so I write my equation right here. I solve that equation for x, and then I plug what x equals back into my picture to figure out these angles. And then I can find what they're asking for by adding these two angles together. So you really have to keep going back and forth with the picture and looking at what they're asking you for. After you do a few of these, it gets a lot easier. All right, let's try another one. The measure of angle MAD is a right angle. Okay, stop. What does that mean? See, we're combining stuff that we've learned already. A right angle is 90 degrees. So they're telling me angle M to A to D is 90 degrees. Well, we use a box for that, remember? So that's 90 degrees. The next thing they're telling us is that ray AY, that one in the middle, bisects angle MAD. That means it cuts it in half. So if the whole thing is 90, what's 90 divided by 2? 45 and 45. That adds up to 90. All right, now I have an expression, 4x plus 1. I need to write an equation. What does 4x plus 1 equal? Well, we just figured it out. It equals 45. So I'll subtract 1 from both sides, and then I'll divide by 4. And it says solve for x, so we don't have to plug it back in. We get x is equal to 11. All right, let's look at one more example. AT bisects angle HAM. So let's mark what that means. That means this angle here equals this angle here. Then the measure of angle MAT is 4x plus 7. So I'm going to label this 4x plus 7. Check. The measure of angle MAH, this is different. MAH, that's the whole thing, is 2x plus 33. Okay. Find x and then find MAH. All right, so I'm not going to set these equal because obviously from the picture they're not equal. The one I marked in green is only half of the purple one, the whole thing. So there's a couple ways you can approach this. You know the two smaller ones are equal, so you could call this one 4x plus 7 as well. And now if I add those two green ones together, I'm going to get 8x plus 14. That should equal the whole thing, which I wrote in purple, as 2x plus 33. And now I need to solve that. So I would subtract 2x from both sides. And then I'm going to have 6x plus the 14. Bring my equal sign down. Those two x's cancel, and I'll just have 33 on the right side. Now I'm trying to get x by itself, so the opposite of plus 14 is minus 14. So that's 0, and I just have 6x on the left side. 33 minus 14 is 19. This doesn't look good. And then I divide by 6, and I get x equals 19 over 6. That doesn't go in evenly. That's actually a mixed number. That's 3 and 1 left over. So you can leave your answer as that, x equals 19 over 6. And that's fine. So I'll write here, find x equals 19 over 6. So that's that answer. The next thing says find the measure of MAH. Well, that's right there. So now that I know what x equals, I can plug it in right there. So MAH is going to be 2 times x, which is 19 over 6, plus 33. If you need to use a calculator, go ahead and use a calculator here. I'm going to do some reducing. 2 goes into 6 3 times. 19 divided by 3 is 6 with 1 left over. So when I add those, I get 39 and 1/3. Another way of writing it is 39.3 repeating. But you can write as a mixed number if you want. And so there's my two answers. So you can see sometimes the algebra isn't going to work out to be a nice number, but that's okay. Usually it will though. All right, so one last thing to talk about. Let's summarize. In this problem, they gave you one of the smaller angles and then the whole angle itself, the big angle. So I'm not going to set those equal. I'm going to have to double the smaller angle, and then I can set it equal to the big angle. In this example here at the top, they told me one of the smaller angles, so I knew the other small angle, and then I added them together to get the big angle. In this second example, they gave me that small angle, and then they gave me the other small angle, so those are equal, so I'm just going to set those equal. And on this third example, we just had to divide the right angle in half and get 45 to set that equal to 45. So there's 3 different types of problems. They're all kind of the same, but they're all a little different on how we approach them. So the assignment is worksheet 10, but I only want you to do the front side. So only do numbers 1 through 5.